Hi guys. All right, so let's talk about the answers to these slides. This is the Unit 4 notebook. We are looking at slides 1 through 10 in this video. You can see we're doing some more triangle congruence, properties, parallelograms, quadrilaterals, and special parallelograms. So it looks like the first one we talk about is again the triangle congruence. So the two new shortcuts we have. And then we have this practice problem here on slide 5. How are the triangles congruent? If we look at this first one, we'll notice we have one pair of congruent sides, another pair of congruent sides, no angles mentioned, but the third side of the triangle is the one they share. So this first one is side, side, side. All right, this next one, we have one pair of congruent sides, another pair of congruent sides. The other thing we do have is the angle in between. Those are vertical angles, so we know they're congruent. So we have side, angle, side. Side, angle, side for number 2. Number 3, you can see we have one pair of corresponding angles that are congruent, a second pair, and then notice we have a pair of sides marked congruent that is not between the two angles. So that is angle, angle, side. All right, number 4. We've again got one pair of corresponding angles that are congruent, a second pair of corresponding angles that are congruent, and the side, this time the side is between them. So this is angle, side, angle. All right, number 5. So for number 5, we have one pair of corresponding angles being congruent. We have a second pair of corresponding angles being congruent. We also would know that the third angle is congruent. That's a vertical angle. We can also find it using the triangle sum theorem. But notice we don't know anything about the sides at all. So since we don't know anything about the sides, we cannot prove it is congruent. Just remember, angle, angle, angle is not a shortcut. That'll get you some similar figures, but not congruent. All right, number 6. All right, number 6. We have some sides that are congruent, a pair of corresponding sides, and a pair of corresponding angles here. So far we've got an angle here and a side. There is some information we know about this triangle that's not given to us, but we already know it. We do have this side that is congruent to itself using the reflexive property, so the one that they share. So we would have a side, another side, and an angle. The angle is not between them, so it's not side, angle, side. We can't use that. But if you do notice, this whole triangle here is actually one big isosceles triangle. So we could say that the opposite angles from those isosceles sides, those base angles, are congruent to each other. And that would be enough to say angle, angle, side, using either side that we know. Or we could even notice that this is a right triangle. And when we have the hypotenuse and a leg. So you could use either one for that one. We could say angle, angle, side, or hypotenuse, leg. Either one would be correct. All right, number 7. Number 7 here. Notice we have one pair of corresponding angles that are congruent, one pair of sides that are congruent. Hopefully you notice we've got another pair of angles here. We've got those vertical angles that are congruent to each other. So we've got an angle, a side, and an angle. Notice that side is between the two angles. So this is angle, side, angle. All right, and finally number 8 here. For number 8, notice we have one pair of congruent sides, another pair of congruent sides. So far 2 pairs of congruent sides. Nothing about the angles, but we do have this one that they do share, being congruent to itself. So this last one would be side, side, side. All right. Let's look at the next slide, slide number 6. We have 2 triangles here. It says, what values of x and y will make these triangles congruent? So if we look at this, we have 2 right triangles. So in order to use hypotenuse, leg, we need to have the hypotenuses, wow, I can't talk today, equal to each other. So if I do 2x plus 8 equals 10x, I set them equal to each other, I could solve for x. Subtract 2x from both sides. We have 8 equals 8x, and x equals 1. So if x equaled 1, then my hypotenuses would be equal to each other. 2 times 1 is 2, plus 8 is 10, or 10 times 1, 10. So that would make my hypotenuses equal to each other. I also want one of the legs equal to each other. We've got these legs here. So we can use that to solve for y. Again, make them equal to each other. Y plus 2x equals 10x minus y. Notice we did find out what x is. X is 1. So I can put that into my equation here. And I have y plus 2 equals 10 minus y. If I add y to both sides, I get 2y plus 2 equals 10. If I subtract 2 from both sides, 2y equals 8, and y should equal 4. Trying to squeeze that all in there. And I can double check my answer. If I put a 1 in for x and a 4 in for y, does it make both of these sides equal? So let's see. 4 plus 2 times 1. 2 times 1 is 2, plus 4 is 6. We check this side. 10 times 1 minus y, which we said is 4. That would be 10 minus 4, 6. So now we have another set of congruent sides that are corresponding. So the answer to the first one is when x equals 1 and y equals 4. What property would I use to prove that they are congruent? As we mentioned, this would be using the hypotenuse leg property. So I have the right triangle, I made the hypotenuses equal to each other, and a pair of corresponding legs. If I write the congruent statement, remember when you're writing congruent statements, you need to make sure you're matching up the corresponding parts. So let me label my first triangle. ABC is congruent, or you can use the congruent one symbol. So ABC is congruent to, so A should be congruent to D. So I'm going to list that first. D, B is congruent to E. C is corresponding or congruent to F. Let me just make sure I have the sides correct. AB, that's the height. I'm sorry, AB is the side we don't know. And DE, again, a side we don't know. So I think I have that right. BC is the bottom, the one we solved here. The second and third one listed here, EF. Excellent. So I have it all in the correct order. All of the corresponding sides and corresponding angles match up here between these two triangles. What is the length of AB? We found the length of AB to be 6. What is the length of DE? This one's a little bit tougher. So notice that's the one side we don't know yet, but it is a right triangle. If you remember, we did have a rule, Pythagorean theorem. I think we started talking about that in like 7th or 8th grade. Oh, good old Pythagorean theorem. So remember when we have a right triangle, remember the Pythagorean theorem looked like this. A squared plus b squared equals c squared. Remember, c is the hypotenuse. So this is equal to 10 squared. And a and b are the other sides or legs of the triangle. So we know one is 6, so 6 squared. We don't know the other one. We can call that x squared. And we can solve this equation. 6 squared is 36 plus x squared equals 10 squared, or 100. If we subtract 36 from both sides, x squared equals 64. And remember, the opposite of squaring something is taking the square root. So I can take the square root of both sides, and I get that x equals 8. So DE, the last remaining side, would be 8. All right, and again, pause this and rewind if you need to go look at those again. Let's look at the next one. All right, so drag the correct reason for each statement below. We are given that WJ equals KZ. So WJ is congruent to KZ. Angle K and angle W are right angles. And I want to prove that JWZ is congruent to ZKJ. All right. So our reasoning for the first one, WJ is equal to KZ, angle K equal to angle W. That's all of our given information. Why can I say angle K is congruent to angle W? We said they were right angles in number 1. So our reasoning for saying they're equal in number 2 is because all right angles are congruent. Why is JZ equal to ZJ? Notice JZ, ZJ. That's the extra side in here. So let me drag that over. That is the reflexive property. And finally, why are the triangles congruent to each other? You'll notice we've got right triangles. When you have right triangles, think of hypotenuse leg. So we've got the hypotenuse here, the line they share, and a leg. So the reason these triangles are congruent is by hypotenuse leg. All right. So let's look at the next one. Lesson 17 dealt with properties of parallelograms. And here are the properties. Opposite sides equal for parallelograms. Opposite sides are parallel. Opposite angles, A and C, are equal. B and D are equal. Adjacent angles add up to 180. So adjacent, if you're going clockwise, it would be the next one around. So A and D are supplementary or add up to 180. D and C add up to 180. C and B add up to 180. And finally, B and A would add up to 180. The other thing, diagonals bisect each other. So bisecting, remember, bisecting means splitting it in half. So BD is split in half by AC. AC is split in half by BD. All right, slide 9 here. We've got a parallelogram and we have to list the congruent sides and angles. So since this is a parallelogram, we know AB must be congruent to DC or CD. I also know BC must be congruent to AD. The angles, angle ABC. Remember, your opposite sides are congruent. Opposite angles are congruent. So the one that is opposite ABC is CDA. Well, there we go. And angle BCD is congruent to the one down here at the vertex A, which is DAB. All right, and if we complete this paragraph below here, since blank and blank are consecutive angles, and there are a couple different angles you can put in here, I'm going to start with angle ABC and angle BCD. So this angle up here, ABC, that big angle, and BCD, this big angle, since they are consecutive angles or adjacent angles, one right after the other, then they are supplementary or add up to 180 degrees. Supplementary. There we go. All right, and finally, slide 10. Determine the value of x in each of the parallelograms below. All right, remember, we said these are parallelograms, so the opposite sides are equal to each other. 2x 2x plus 15 should equal x plus 15. We can solve that. We can subtract an x from both sides. 2x minus x is just x. So x plus 15 equals 15. If I subtract 15 from both sides, I get that x equals 0. All right. And for the second one here, we're looking at the angles. We have two consecutive angles. So remember, consecutive angles must add up to 180 degrees. So 14x plus 5 plus 35 should equal 180. If I add those like terms together, they're both together on the left side. I get 14x plus 40 equals 180. I subtract 40 from both sides. 14x equals 140. Divide both sides by 14. You should end up with x equaling 10. All right. I hope that helps. Have a wonderful weekend.